as if you're tuning into this, you would be aware that this was left up from yesterday. I mean, I erased some of the content on there due to needing this for other classes, but from these diagrams over here, do we see anything correlation or that's correlated over on this side? Okay, the answer to that would be yes. Okay, let's just work from the top down. For instance, do we see replication over here? Yes, we do. Okay, how would we know that? First of all, I'm telling you that for one, because we're not mind readers, but how would you know that replication is taking place here? Say that again?
I simply don't know.
Oh, okay. Does this not look familiar? It does. Okay. So, can you tell me the difference between this and this then? Okay. Well, we haven't made anything to that yet, but okay. But what happens in replication? You're replicating your serves. So if you have a successful serve, you want to replicate it. You want to make it again. You have a second successful serve. Replicate it. Make it again. Okay? But these are not both replication. How do we know that this bottom one is not replication? Because it's what? Okay, I thought you said it had an R in it. That's why I wanted to make sure I was hearing that correctly. We know that on the outside is RNA. How do you know that? Because there's a uracil in it. Does that sound logical? Left outside. Do we understand that? And right outside. I didn't say middle, but right outside now. Okay? Because if we're saying that we understand this, well then, what did we say from yesterday? If you know it today, chances are you're going to know it tomorrow. If you have to memorize your music for band, if you knew it on Monday, you should know it on Tuesday, right? You get on Wednesday. Now, you might forget bits and pieces are here and there, but we're trying to help you with this, okay? So, what is it that holds this DNA molecule together, these dots here? You did that in your activity, right? What was the hydrogen bonds in your activity? Hot tamales, okay? So, something must be splitting this molecule apart. It's an enzyme, this enzyme. DNA helicase. Okay, so if DNA helicase separates them,
330 today?
yes,
Okay, thank you.
yep. So DNA helicase separates this. Well, there's another DNA molecule that puts it back together. If this unzips it, what zips it back together? It's DNA something. Polymerase. Okay? DNA. I can't fit it inside of there. Okay? So, can something with DNA in it do this activity down here if it's got RNA in it? The answer is no. Well, what is it that will split a DNA molecule so that transcription can begin? Because we see that over here, transcription. It's also an enzyme. RNA polymerase. Okay? RNA. I'm just going to abbreviate that because I'm running out of space. RNA polymerase. Okay? So we've talked about this. Well, what about transcription? Is that process taking place? What does a scribe do in transcription? Reads it. So what is being read? The DNA is being read. Okay? What is doing the actual reading? Okay, do we see messenger RNA up there? Yes. Yes, we do. And I'm going to do something even specific like this. Why am I putting boxes only around 3 nucleotides? Because those are codons. Okay? We see that. That's associated with messenger RNA, or codons. Okay? I'm going to throw this marker at you if you get this wrong. Why is that significant, Blob? A little more specific. You're close.
What they need to do.
Okay, you're getting a little closer. Can I still throw this at him?
Yes, you may. Go ahead.
I might miss. No, he's got the bow tie on. I didn't know that's what you called that.
Oh.
I didn't know that called the emblem for Chevy was bow tie. I said, you got the bow tie on there. I can't do that to a Chevy guy. Or is that just a sweatshirt? It's Chevy? Okay.
Not by choice.
Hey.
We don't know about
Oh, okay. Do you drive a Ford? Okay. All right. Okay.
Son's my youngest daughter now.
All right. So blob there. Why did we call you blob?
That what DNA.
Right. Because you were that enzyme that's looking for this guy right here. Because that's telling where that process is supposed to start. Okay? So any 3 letters of messenger RNA is called a specific what? Codon. Okay? So those codons specify for specific what? What do you suppose these things are called? Say that again. Amino acids. Well, how do these know how to assemble themselves? Well, it comes from the code of DNA in the nucleus that's read by the messenger RNA. So that message leaves the sideline, we said that too, leaves the sideline, goes out to the huddle, out in the cytoplasm on the football field. So your messenger RNA, so you take that message out to the huddle, and that play specifies where each and every one person is supposed to go. So the directions we had said, here's Mr. Williamson, here's Blob, okay, and a few more blobs behind him, just tell him where everything's supposed to go. This process is transcription. Messenger RNA is reading the directions. It leaves the nucleus out to the ribosome and starts assembling these amino acids. Okay? You might notice that maybe we're kind of jumping. Does it seem like we're jumping back and forth and back and forth? Are we confusing you when we do that? I see and I hear no. Okay. What part might be a little confusing?
It's just the jumping back and forth is really
Okay.
confusing me just a little bit is all it is pretty much. Just jumping back from this to this.
Okay. We can. I just want to wrap this up here. What do you suppose these things are that are going to match up with this? If these are codons, like you said, these must be what? Anticodons. Okay. So this whole chapter dealt with what? Protein synthesis. Okay. So someone start giving me some nucleotides. C. Okay. So now, do you want to see the replication part or the transcription part? Okay. So, what do I want to say? What molecule does the process of transcription? The scribe, the reading part of it. What RNA? mRNA. So this is DNA. This is messenger RNA. Okay? So what is going to bond to cytosine, but only on RNA now? Guanine. Okay. And if we had to put these complementary base pairs for DNA, this is called what? Okay, adenine and cytosine. Okay? Is there any questions about replication? None. Okay? So now, once this messenger RNA has read the directions, because those directions have to get out to the ribosome, because can DNA leave the nucleus? No, it cannot. Is RNA found in the nucleus? Yes, because it has to read, we just said it has to read the DNA. A 3-letter segment of messenger RNA is called a what? Codon. Okay, and we've got 2 of them. Okay, what enzyme is specific to transcription? It's not DNA helicase, because that's replication. It's not DNA polymerase, because we said that seals it together. It's another polymerase enzyme. RNA polymerase does that. So how many enzymes have we talked about total? 3. DNA polymerase, RNA polymerase, and DNA helicase. Okay? So I'm just going to put HEL, so for helicase. But that's not right, is it? No! I was seeing if you were paying attention. We listed helicase last. That's what threw me off. Okay, so that's RNA polymerase. Okay, this message leaves the sideline, leaves the nucleus. Where is it going? To where? To the ribosome. Okay, so now we've got this, so 1, 2, 3, 4, 5, 6. We've got CGU. And we've got UAC. Okay? So if what I just drew down here are codons, these are anticodons. Well, what does transfer RNA specifically pick up? Amino acids. So how does it know what segment to put them in? It's encoded in the message. The message is in what form? What type of RNA? No. It's in the name. Messenger RNA. The message is in messenger RNA. So it's telling this how to hook these up. So if this is transfer RNA, what are the 3 nucleotides we'd put here? Okay? And if this was another anticodon of transfer RNA, what would that be? Right? You got a disgruntled look on your face. Okay? Because cytosine bonds to guanine, right? Guanine bonds to cytosine, right? And then uracil would bond to that adenine. Okay? We just didn't quite put them on there because my drawing capabilities are not very good. Maybe we should have, I almost said Mrs. Herbert down. No, Mrs. Terwilliger down here. She could do a better job of this than I could. Anybody in art class here? Yeah. This isn't very good drawing, is it? Okay.
That's probably better than what I can draw.
Okay. So what part of this is confused? Okay. So again, messenger RNA is reading the DNA. What is that called? Transcription. Scribes read. It is a message. That message has to get to the ribosome, and it's decoded and tells these amino acids how to link together. Well, how do those amino acids get there? Something specifically is picking that up and bringing it there. And it's called what? Transfer RNA. And when I'm put inside of a box here, what are those called? If these were codons, those must be what? Anticodons. Okay? There. Okay? Can we close the book on what's this process called then? If this is transcription, this must be what? Translation. So transcription takes place where? In the nucleus. Where does translation take place? At the ribosome. Okay? Now, as I'm looking up here, is there anything up here that we have skipped, do you think? Okay? So, we've seen that process. We just talked about this. We just talked about that. Ribosome assembly, well, that takes place at the ribosome, and it's starting to assemble these, which are called what? Amino acids. Okay? Where is messenger RNA found? It's a trick question. Nucleus and ribosome. Well, and cytoplasm and ribosome would be the same thing. Okay? Well, if the message is coded on the DNA, why doesn't DNA go out to the ribosome? It can't leave the nucleus. That's why that has to be coded in a message on the RNA and then translated at the ribosome. Okay. Well, where's transfer RNA found? What, say that again? Because I could have swore I said, I don't know. That's what it sounded like. I don't know. Ribosome. Okay. So, ribosome. Okay. So, basic definition of a codon. Of mRNA. Anticodon. Of? Yeah, we need to be a little more specific. That's why I say and. Okay? So, DNA is found in the nucleus. What's its function? Has genetic information. How many strands is there? Two. It's a double helix. Okay? It lacks what nucleotide? Uracil. Okay? So really, this entire process is protein synthesis, right? So you could say that DNA is a very basic what? What do amino acids make? Proteins. So DNA really is a basic protein, if you want to look at it that way. Have we just about had enough? Okay. You have vocab terms that were handed back to you. Okay. There's no essays. But you may have to make an interpretation of codons. In other words, did we just roll our eyes? Huh. Unless there's something significant up on the ceiling there, because I thought I saw us look up at that. Oh. Oh, well, that could be. That's just as good an explanation as any. Okay. So, using that table, was it on page 340? 338. See, we've been using it so often that you people know what page number it's on. I was off. I didn't win on the Price is Right. I went over on my bid. Okay? I do, yeah. Dang it. Okay, so do you think you can name these two amino acids? With the table. Is there any confusion on how to read this table? Because if you're nodding your head yes, that we understand this, that means we're done. Left outside. Middle. Okay, right outside.
Wait, so we're gonna have to draw out, like from DNA, and then we have to go to mRNA, and then we have to transRNA.
And then,
To name them?
yes, not all of them, just like 2 of them. Okay?
How long is this thing? How many pages?
I don't know.
Or is it like 2 pages?
Average question amount would be
Well, probably 15 general questions, probably 20 vocabulary terms, 15 to 20. Because you have 15 of them right now. Okay? For those of you who chose to keep your vocabulary evaluation, that's probably a good idea.
There is one thing that you are forgetting. There's 3 of them. Bonus questions.
I haven't got that far yet. Okay? So then, if that is it, I'm going to erase this.
sounds good.
Okay. Well, I suppose we can leave that up for the students when they get back. Okay. So we're concerned about these bonus questions, huh? Okay.
Let's have some football questions.
Or, like cartoons.
Oh, yes, because I erased that. I was getting ready for next week. Just leave it on your table, and I will pick it up after class. Can you read that?
That's easy. That's easy.
Well, then we shouldn't do it. If it's easy.
That's high Q.
It's not a football question.
I know it's not a football question, but I know who the person is.
Oh, okay.
I'm not telling you guys who it is.
Okay, I don't know if I'll spell these right, but Johnson & Johnson is one vaccine. Name one of the other two types of vaccines you can get for COVID-19. So JJ is one, blank is another vaccine. We'll just, yeah. Okay, there are two of them you could give. You don't need to give both of them. You just need one of them. Yes, yes. So we'll catch up to you next time.